Rồi đến gì? Là con nào? À, Good afternoon, students. How are you doing today?
Good afternoon, sir. We're doing. I can speak for myself. Tired, tired.
That makes two of us. The more, sorry, that makes two of us. I'm very tired, but I'm trusting that you guys will do enough to keep the class going tonight. All right. I think I've run out of questions. Can somebody find a question for me, please? All right, never mind. Yeah, do that for me. Somebody can find a stationary point question for me, please. Thank you. A stationary point question. That's all. All right. So as promised, I have to move along. I have to move along because time is of the essence. Um, I am behind. I'm not unsure at all. I'm behind, and I was going to give you a stationary point question to do for me in class now, but I still want the question. But It's a question that is going to be assigned to you for additional work. We need to do a we need to do a dictionary point question every day, so that by the time it gets to exam, we are fully ready. Okay, so we're on to implicit differentiation, and we need to just look at some quick examples, and then we'll run into some actual stuff. This is not difficult, guys. Please ask you to open your minds. I really don't have the time to be. Are you understanding? Are you understanding? Talk to me. Not tonight. We need to get it out of the way so we can just move on. So we're looking at implicit differentiation. So for example, if I give you x squared plus 2xy plus y squared is equals to 12, comma, find dy by dx. Want you guys to all follow what I'm saying here. I'm going to be differentiating as normal. However, once I differentiate a y, I must end that differentiation with a dy by dx. So for example, I'm differentiating x squared. When I differentiate x squared, I'm going to get 2x. That's it. It's finished. And I'm going to differentiate 2xy. To differentiate 2xy, you recognize that this is a product. So watch me. Plus, it's a product. This is my first. This is my second. My first is 2x. My second is y. Oh, crap. 2xy. That's my first. And this one here is my second. So in differentiating, I'm going to say the first, 2x, times the differentiation of the second. When I differentiate y, I'm going to get 1. But because it's a y, I'm going to put dy by dx. Plus the second, plus y, times the differentiation of the first. When I differentiate 2x, I get 2. That piece is done. Let's go again. The first, dy by dx. Rubbishness. 2x. The first, I call it, I write it back. The first times the differentiation of the second. When I differentiate the second, when I differentiate y, I get 1. So I put 1, and then I write, because it's a y, I have to write dy by dx. Plus the second, because I call the second and write it back, you notice I just write by the y. There is no need for dy by dx because I did not differentiate this y. And then I'm differentiating the 2x, I'm going to call it 2. And then now, this is going to be plus the differential of y squared is going to be 2y. But because it's a y, I'm going to have dy by dx. Equal, the differential of a constant is always equal to 0. Any questions?
None yet.
Okay. So now, I have square brackets right there that I must fix up. Two x. This is 2x times 1, dy by dx is going to be 2x dy by dx. It becomes 2x dy by dx plus 2y. plus 2y dy by dx. I'm grouping I'm grouping all the dy by dx's together. So I'm going to say 2x dy by dx plus 2y dy by dx plus 2x, this 2x plus that 2y is equals to 0. Can you agree with what I have so far?
All right, sir. Following so far.
Good job. Even if it's just one person.
Good evening,
Very good.
sir. Just got in the class, so bear with me.
Ah, okay, touch. So you're given a function, x squared plus 2xy plus y squared equals 12. And you're asked to differentiate implicitly to find dy by dx. When I differentiate x squared, I'm going to get 2x. This is a product. But remember, it's an implicit differentiation. It's a product. I must identify my first. I must identify my second. I'm calling 2x the first, and I'm calling y the second. It's the first, see here, times the differentiation of the second. When I differentiate y, I'm going to get 1. But because it's a y, I have to write dy by dx. Plus the second, plus y, times the differentiation of the first. When I differentiate 2x, I'm going to get 2. That ends that middle term. And then I'm differentiating y squared. When I differentiate y squared, remember, I'm differentiating normally. But if I'm differentiating a y, having done the normal differentiation, I must include a dy by dx. So y squared, when I differentiate y squared, I'm going to get 2y. See here? But because it's a y, I have to write dy by dx. Equal. Differential of a constant, 12 is 0, equals 0. I'm removing my parentheses. So 2x times 1 is 2x, times this dy by dx is 2x dy by dx. This is it. And 2 times y is 2y. And this, so that this here in parentheses works out to be these two terms here. And I'm writing back my 2 by dy by dx, and I'm writing back my 2x here. And of course, all of that is equal to 0.
Yeah.
My next step is to group all the dy by dx's. So 2x dy by dx is right here. Plus 2y dy by dx is right here. Plus 2x plus 2y plus 2x plus 2y equals 0. So that's where we got to. So we're going to continue now.
Okay, sir. Thank you.
No problem. So I'm going to be grouping all the dy by dx's. So this is what I'm going to have. I'm going to have dy by dx. I'm going to have dy by dx. And this is going to be equal to 2x plus 2y. And this is plus 2x plus 2y equals 0. I want dy by dx to be the subject of the formula. So what I'm going to be doing here is to say, you know what? Dy by dx times 2x plus 2y is going to be equals to minus 2x minus 2y. Tell me if you see how I got that.
Yes, sir.
Good job. Now,
Wait a sec, with the positive 2x and the positive 2y over.
This could also be written as negative 2x plus 2y. Tell me if you see that.
Yes, sir.
Yes, sir.
Good.
Sir,
So now, go ahead.
sir, so dy by dx plus dy by dx is just dy by dx.
Right, so dy by dx, no. So what I'm going to do, is to divide both sides by 2x plus 2y. Two x plus 2y. What now happens is that all of this 2x plus 2y cancels this 2x plus 2y. But what I now have here is 2x plus 2y over 2x plus 2y, but this is a minus 1. Can you see that?
Yes, sir.
So all of this now cancels with that, and it's going to leave a negative 1. So therefore, dy by dx is going to be equal to negative 1. This one works out kind of very nice. I didn't have anything to substitute into anything. Any questions?
All right, sir. Pause this and write off the example, no?
No problem.
Yes, sir. Good night. Good evening.
Yeah, Nigel.
What I go on? You can explain the line above grouping all the dx, dy, dx, sorry.
Mhm.
We're not sure how you get that line.
All I'm doing is just putting all the dy by dx's together. So you notice that this 2x dy by dx I put out here, so? And this one all the way out here, 2y dy by dx, I just put it closer here.
Also, yeah, start work from, is it the same line there with the cursor there now?
Mm-hmm.
Yeah, explain that line there for me. Start from the line there.
I can't start from this line, I have to go from here so to get this line.
No problem.
All right. So you're given x squared plus 2xy plus y squared equals 12. It's an implicit differentiation. You're asked to find dy by dx. You are going to be required to differentiate normally. You're going to be required to differentiate normally. Normal differentiation, except when you differentiate a y, you must write dy by dx. Except when you differentiate a y, you must write dy by dx. So this is x squared. When I differentiate x squared, I'm going to get 2x. That's finished. I'm looking now to differentiate 2xy. I recognize it's a product. The product rule says the first times the differentiation of the second plus the second times the differentiation of the first. The first is 2x times the differentiation of the second, which differentiate y, and we get 1. But because it's a y, if I'm differentiating, I'm going to have dy by dx. Plus the second plus y times the differentiation of the first. When I differentiate 2x, I'm going to get 2. See? Times 2. Differentiation ends there. Then I'm going to now differentiate y squared. When I differentiate y squared, I'm going to get 2y. But because it's a y, I'm going to have dy by dx. Now, I'm just removing these parentheses. This 2x is this 2x here. 2x times 1 is 2x times dy by dx is simply 2x dy by dx. 2x dy by dx. Plus y times 2 is 2y. This plus sign is this one here. And 2y dy by dx is simply 2y dy by dx equals 0. Now I'm grouping all my dy by dx's. I'm putting all the dy by dx up front. So 2x dy by dx goes to the front. So does this other dy by dx, 2y dy by dx right here. The terms containing no dy by dx, I'm going to put one side. So see here, 2x is right here. And 2y is right here, equals 0. So I'm taking out my dy by dx because that's what I want to find. So I'm factoring the dy by dx. When I take the dy by dx from here, I'm going to have 2x left, see here? And when I take the dy by dx here, I'm going to have positive 2y, see here? Plus this 2x right here, 2y right here equals 0. I want to isolate the dy by dx. Isolate means I'm keeping the dy by dx alone on one side, and everything else without a dy by dx goes to the other side, which would be this 2x and this 2y. But this 2x, positive 2x, I'll have to subtract it from both sides in order to eliminate, so it becomes a negative 2x. And this 2y, I'll have to subtract it from both sides in order to get rid of it, so that becomes negative 2y. But I recognize that minus 2x minus 2y, I can factor out the negative sign and get negative 2x plus 2y. And you will recognize if I distribute negative 1 by 2x, I get negative 2x. And negative 1 by positive 2y, I get negative 2y. So now I'm dividing both sides by 2x plus 2y so that I can get rid of this. Anything that is beside the dy by dx, that's what I'm going to divide by. That determines what I divide by. So I'm dividing one side, I have to divide the other side by it. But these two cancel out, so I'm only left with dy by dx, see here? But when I divide here, I recognize that this is 2x plus 2y, and this is 2x plus 2y, so those two cancel. Leaving with this negative sign here, which is going to translate to be negative 1. So my dy by dx is equal to negative 1.
That's tricky. Oh, that's tricky, sir. That one tricky.
That's second line, that's can.
All right, sir. Let me see.
One time.
All right.
No, hold on.
Fine.
Connor, go ahead.
The second line, that's sir. Can go through one more time before you reach the.
Which second line? The one all the way up here, sir?
Yes, sir.
No, man, you tell me, you go through it
No, man, me get where you say below that. I just hope this one. I get distracted, but I look good by work.
What do you want me to explain?
Or you reach
from this line here to this line?
Yes, sir. That's the problem.
When I differentiate x squared, what do I get?
2x.
See it here? 2xy is a product. Calling me 2x the first term, calling y the second term. Is the first, I'll write it back, times the differentiation of the second. When I differentiate y, I'm going to get 1. But because it's a y, I have to write dy by dx.
Okay.
Plus the second, second is y. So it's plus y times the differentiation of the first. When I differentiate 2x, I get 2. You notice I don't write any dy by dx because I'm not differentiating a y, I'm differentiating a x.
Yeah.
And then when I differentiate plus, put back my plus sign. When I differentiate y squared, it's going to give me 2y. But because I end with a y, I have to write dy by dx.
Okay.
Alwyn, your turn.
All right, sir. Second to last. Yeah. The factorizing part, so that equal sign. Yeah. You see how we factorize out the negatives, the negative sign. So you could use the 2 as well.
I could have, but if I use the 2, you recognize that it wouldn't help me right here.
You just have x plus y.
I'm going to have negative 2x plus y, but I wouldn't, chances I wouldn't even recognize that I could cancel out the 2x plus 2y. Because I remember, say the 2 could have factored out from 1 yesterday, you know. You follow what I'm saying?
Yes, sir. Yes, sir.
So that's the reason. Did I answer your question, Alvin?
Yes, sir.
And Fahim, you had unmuted and then you mute. You have a question? Oh, sorry, you had raised your hand, sorry.
Yes, sir. I'm in not at that same section. You say you factor out the 2x, the negative 2x and the 2y,
Mm-mm.
and the
A
wait,
factor with a negative sign. Minus 2x minus 2y, a factor with a negative sign. So I'm just going to have 2x plus 2y.
oh, okay, sir. Okay. And then you have, oh, okay, sir. All right, I'm good now.
Mhm. Any other questions?
Not yet.
Okay. Start off with please.
Sir, we're supposed to work that out?
No, man, just sit and look at it.
Sir, we
Thank you.
finished.
Okay, thank you, Mr. Andrew, because I know you know better. You finish it? Anybody finish?
Not too far out, sir, just a month.
All right, then, cool.
Sir, I'm not sure about the differentiation part. I may make a mistake with the x square or y square.
Sorry, Alwyn. You're saying?
I didn't say anything, sir.
All right, sorry. Somebody was saying something. I was just stepping away when I heard. Andrew, was it you that was saying something after we spoke?
Differentiation.
All right. All right, never mind. Are we finished with the question now? Guys, it's a yes or a no. I'm not doing this tonight. How many to go? Are we finished with the question?
Sir,
No, sir.
no.
All right. Let me know what is happening. Let me know when you're done, please. just a public service announcement, students. As I said before, I'm not doing this tonight, you know. So as long as you take, I did say to you, talk to me.
Sir, ready when I'm ready, no, sir.
No, Nigel. I said, when you don't get an answer, no, talk to me. And if I don't hear it, I'm not going to unmute. I'm not doing this tonight.
I have a challenge with it, sir.
Okay, right. All right. So we're differentiating. Y squared. What's the differential of y squared, Nigel?
Sorry, go again, sir. 2.
What's the differential of y squared, Nigel?
2y, sir.
Okay, thank you. So it's going to be 2y, but because I'm differentiating a y, I must end with dy by dx. Got that?
Have that, sir.
Good. What's the differential of 2x? I mean, x squared.
You just give the answer, sir.
All right, 2x. Good. And now I'm differentiating. I'm putting my minus sign here, and I'm opening my parentheses, just like I did in the first one.
Oh, this is slap it.
So this is going to be my first. This is going to be my second. So the first, x squared, times the differentiation of the second. When I differentiate y squared, I get
2y.
and
2y.
2y
And?
dy by dx.
dy by dx.
Yeah, have that.
Plus the second, y squared, times the differential of the first, which is?
So that
2x.
I swear already.
2x. Oh,
Well, there. I was looking at what you.
Oh, I messed up the part.
Equals
sir,
0.
explain that part there again. The 2x part there, explain that part there. Oh, I get that.
First times the differential of the second plus the second times the differential of the first. You're differentiating a product. It's the very same thing, Papa, that we're doing in the first part of our differentiation. The only thing that we're doing different now is looking at the implicit as opposed to an explicit differentiation.
So I got up to there. Fine. But next line now is where it gets. In fact, the line after that, when we're supposed to group, then the next line and the line after that. But let's see how it works out. See if I have the right.
Get up to the y squared, but hit that from a sir.
2 by dy by dx. Sorry, right here you're talking?
Yes, sir.
The first, x squared, times the differentiation with second. When I differentiate this, y squared, I'm going to get 2y. But because I'm differentiating a y, I have to put dy by dx. Plus the second is y squared, so plus the second plus y squared times the differentiation of the first. When I differentiate x squared, I get 2x. So now,
before you move on, sir, is it safe to say that every time I go compare the first and the second, it always have the 2xy together? So we can see the difference with the first and the second.
it is always fair to say the first times the differentiation of the second plus the second times the differentiation of the first. Different functions operate differently. So I can't tell you say yes, it's going to always be like that. Different functions operate differently. So just remember their product rule formulation. The first times the differentiation. Yeah, man. So just the same thing, man. Just do the something. And the same something. Watch me again. You're differentiating. You notice I put my when I'm doing my product.
That is where I have a problem, sir, because I did not put the parentheses. I didn't big bracket. Didn't start it.
You need to follow your teacher charge. I'm going to charge you. That's one red stripe line.
Take that one.
A case that is. All right. So you need to put it in parentheses. See it here? Again, I'm putting it into parentheses. So let us go with the differentiation now. It's the first. Go ahead.
I put the parentheses in there, sir, but it's where I started it. I actually started it at the 2x. I started it at the 2x instead of
right here, sir?
Yes, I put it right after the plus. So
oh no. Right, no. Since we're starting our product rule, the first, x squared, times the differentiation of the second. When I differentiate y squared, I'm going to get 2y. Because it's a y, I'm going to have dy by dx. Plus the second, y squared, times the differentiation of the first. Differentiating x squared, I'm going to get 2x. And then, hold on a minute, please, guys. All right. I'm back to this side. Oh Lord, where's the pen? Where's the pen? Where's the pen? Where's the pen? Hold on. All right. So now I'm writing out my 2 by dy by dx. I'll also write back the 2x. I'm going to put this here. I'm going to fix up this first before I remove the parentheses. 2x squared y dy by dx plus 2xy squared equals 0. Tell me if you see that. Do you agree with that?
Yes, sir. I have that.
Okay. Now I'm going to remove the parentheses. When you have negative signs, you have to be very careful. You have to be very careful with the negative signs. Watch this now. That becomes negative 2x squared y dy by dx. But remember, it's not just that the negative sign controls. It's everything in the parentheses. And then I'm going to be grouping
Problem is.
putting all the dy by dx's together, dy by dx. And then I have another. So this is negative 2x squared y dy by dx. Then I'm going to put my 2x minus 2x y squared equals 0. I'm factoring out my dy by dx. So dy by dx times 2y minus 2x squared y plus 2x minus 2xy squared equals 0. I'm keeping all.
Sir,
No.
I'm a fire drill. I have to leave the building.
Oh, Jesus. Fire drill at 6 o'clock?
It's mega, sir.
All right. You can join on the phone? Even listen?
I'll try, sir.
All right, cool. Okay. So now I'm keeping all the dy by dx's on one side and everything else on the other side. So that now becomes a positive 2xy squared and a minus 2x. Look at that and tell me if you agree with it.
Yes, sir, I get that.
Good job. Then what I'm going to do, I'm going to divide both sides by 2y minus 2x squared. What you know to divide both sides by? Anything that is beside the dy by dx. So now this cancels that. So we're going to have dy by dx is going to be equal to 2xy squared minus 2x all over 2y minus 2x squared y. You know what? This can be factored out. I can, as you clearly see, I have 2's in all the 4 terms. So of course, you know, I can just cancel, I can factor out, not cancel, but I can factor out all the 2's. In the numerator, I have x's that are common, but in the denominator, I have y's that are common. So what for sure I can do is to factor out all of that. Based on the questions that you'll be given, it's either for you to find the tangent or the normal. And in whichever case you're going to be doing, finding the tangent or the normal, they are going to be giving you values of x and y for you to substitute so that you can find the exact value of dy by dx. So when you get to this stage, I'm just showing you how to make life easier for you. I will not ask you to factorize this thing here because I don't want you to do double work. And next thing you factorize, I'm gonna make mistake. So the aim of this exercise at this point in time is to teach you how to do the factorization. All right, let me extend the question and show you what I'm talking about, because some of you not going to have a clue to what I'm referring to.
So you're going to zoom out? Okay.
Good night, Logan.
Thanks, sir.
What was I going to do? Y squared plus x squared minus 2x squared y squared plus x squared y squared plus x squared minus 2x squared y squared is equals to how much? Is equals to, oh, it's not 2, it's just x squared y squared. What's that, 6? X squared y squared equals, yeah, y squared y squared plus x squared minus x squared equals 6. All right. So the question is asking to find the equation of the tangent. The question is asking to find the equation of the tangent to the curve at that point. At the point 2, negative 1. At the point 2, negative 1. So we have calculated the value of dy by dx. We have calculated the value of dy by dx. Now we need to evaluate what dy by dx is, the calculated value of dy by dx. Watch me. In this first example, we got an exact value for dy by dx. Dy by dx was equal to negative 1. In this here example, dy by dx is all of 2x y squared minus 2x over 2y minus 2x squared y. So in order to find a value for dy by dx, I am going to
substitute 2 as x and negative 1 as y.
Very good, Papa. Excellent. Excellent. That's the easy part. So now, dy by dx is going to be anywhere I see x, I put 2, anywhere I see y, I put negative 1. 2 times 2 times negative 1 square minus 2 times 2 all over 2 times negative 1 minus 2 times 2 squared times negative 1. That is going to be equals to 2 times 2 is 4. Negative 1 squared is positive 1. And 1 times 2 is 2, and 2 times 2 is 4. So that is going to work out to be 4. And minus 4. Hey, interesting. 4 minus 4. And this is going to be 2 times negative 1 is going to be negative 2. And 2 squares is 4. 4 times negative 2 is negative 8. And negative 8 times negative 1 is positive 8. So what I'm going to have here is 0 over 6. So therefore, dy by dx is going to be equal to 0. So the gradient is equal to 0. The question says to find the equation of the tangent to the curve. To find the equation I need two things. One, a point, which is going to be 2, -1, and 2, the gradient, which is going to be equals to 0. M is the gradient. It's going to be equal to 0. So to find the equation, I'm going to need two things. I'm going to need 1, a point, and 2, a gradient. I'm going to need a point and a gradient. Remember, to find the equation of a curve, I'm going to need two things. 1, a point, 2, a gradient. To give the point, you have to know calculate what the gradient is. That's why you have to find dy by dx. So now the equation is going to be given by y minus y1 over x minus x1, which is equal to m, the gradient. Y minus y1 over x minus x1. Always remember that the x value is written first, followed by the y value. So what is going to happen here is going to be y minus y1 values minus -1 over x minus x1, x minus 2 is equal to the gradient, which is 0. Are you following me?
Yes, sir.
Yes, sir.
All right. Now, this works out not to be y plus 1 over x minus 2 is equal to 0. If you look at it there, you'll recognize that my 0 is really 0 over, my gradient is really 0 over 6. Can you see that? That the gradient here, but of course, you know that 0 over 6 is 0. Can you see that the 0 over 6 here?
Yes, sir.
Yes, sir.
And 0 over 6 is 0. So if I use my gradient here as my 0 over 6, which is really 0, I now have two fractions separated by an equal sign. I'm going to cross multiply. So I'm going to have 6 times y plus 1 is equal to 0 times x minus 2. I have 6y plus 6 is equal to 0. 6y is equal to -6. Divide both sides by 6. It implies y is equals to -1. It implies that y is equals to -1. And I don't like that question. It's not, I mean, I wouldn't give you a question like that in the exam. But anyway, let me just explain what is happening because I don't know what is coming on the exam. So the equation is going to be of the form y equals mx plus c. Y equals mx plus c, right? So let me show you another way of doing the calculation. Your y value is -1, so you can put your -1 there. Your gradient is going to be 0. M is a gradient, 0. So 0 times x is 0 plus c. So technically I have -1 is equals to c. That -1 is right there. The y-intercept is going to be -1. So that is going to be the equation of the curve, y equals -1, because the gradient is 0. So I did it two ways. The way in red, I don't like, but I know some students do it that method. The way that I did it first in gray is a method that I much rather prefer, because it shows that, you know, some levels of understanding, and I can see where you make the mistakes and you can get partial credit. The other one, when you just fling numbers in there, the value of, you know that y, from here, you know that y is equals to -1. And then you know that x is equals to 2, but the gradient is equals to 0. That's an equal sign plus c. So -1 is going to be this -1. 0 times 2 is this 0 right here. And plus c is here. So you can get c equals 1. So the y-intercept is going to be equals to -1, right? And that which ends up working to be the equation of the straight line. Of the curve. Equation of a curve. It's not a straight line, it's a curve. Oh, you know, sir? It's all of them square in there, so tells that is a curve. Straight line is linear. All right. It's a lot to swallow. You should know how to do the differentiation by now. Where do you want me to pivot so that you can start writing or taking screenshot? I prefer if you take a screenshot so you can look at it, because I want to give you a question to work for me. How do I do this though? Let me see if I do booklet form, if you can see both pages at the same time. Nope. It's not. Why is it not showing though? Oh, maybe because I'm using ink. All right, can you screenshot that for me, please, guys? Let me know when it's completing the screenshot. Very important topic here.
Gotcha, sir.
Thank you, sir. I'm expecting at least a 10 marker from this. Could be more, but at least a 10 marker from this. Take that second page, and those two pages will be the question, the end of the question, start and end of the question. And then I'm gonna, all right, cool. And then I'm gonna, hi, Chrissy, how you doing? I'm gonna do, give you one to do for me, please. Are there any questions? All right. Have you completed the screenshot, Kahi?
Yes, sir.
All right. I'm gonna give you one to do for me. All right, so I'm not going to, for the interest of time, I'm not going to write. The question normally comes like this. Find the equation of the tangent to the curve for at the point that. Okay, let me write it. I hope this one works out better at the point 0.1. All right, I'm giving it 10 minutes. Quick and fast, please. Thank you.
Sir.
Yes, Papa.
For dy over dx, we get 12x squared minus 2y over 2x plus 5.
Okay.
For the points, we get negative 2 over 5. For the equation, 5y minus 1 over 2x.
Okay. I love your attitude, Alwyn, and I mean, you know, this will take you very far. But did anyone else complete the stuff? Anybody agrees with what Alwyn has?
So it looks like it's
Sir,
Yes,
at
sir,
two,
but
at
also,
two, at 2 over
quite
5, I'm getting that, sir.
not quite finished, but it's
All right. Okay, so 2 of you. All right. So Carno, did we get the differential that like what Alwyn got?
No, sir.
I
get 2y minus 12x squared over 5 minus 2x.
Okay, Taj, what? Okay, go ahead. Sorry, Carno, go ahead. Over what?
5 minus 2x.
All right, cool. Taj, what you got? You got anything? You got what Alwyn got, or you got what Carno got?
Sir, it's leaning towards what Owen has. I'm not finished quite yet, but it got to a point where grouping dy by dx, I have a minus 2x dy by dx plus 12x squared plus 12x squared minus 2y plus 5, and then I took the 5 over. So that's the next line that
All
I'm
right.
in.
All right, finish up. I'm not going to do it yet. Finish up. Anybody else get anything?
it's the same thing that Lakana got.
Who is that?
Kenneth.
So you in a class the whole night and you're a teacher?
Also because me in the office, so me in and out. So me never want just come out, you know. So yes, sir. So me get the same thing what Lakana gets.
Okay, all right, no problem. All right, Connor, I see that response, Connor. I will soon respond to that, Papa. All right, guys, I'm gonna give you a couple more minutes because it doesn't make sense. I give you the question and then end up doing it because I want to make sure that you're understanding what is happening. I'm gonna give you about 3 more minutes to just finish off your thoughts. Shantia, you normally at this point in time drop an answer to me and I've not seen anything from you yet. Come, Shanti. Don't sleep. I know you're tired, my love. You said that you're tired, but come. Jean, I need to hear something from you as well. The more you are sleeping.
So I'm here, sir. I'm just really and truly just trying. I'm trying, sir. I'm making progress.
Chris and Adrian, you are not with us tonight. Raji, I need to hear from you. Shane. I tell you. Mr. Richards, you're here? No, something is wrong.
Hi, sir.
What is wrong? What is happening?
Not feeling well, so if I'm not talking up tonight, that's why.
Okay. Is it the flu?
No, it's a stomach bug.
Oh, gosh. Because I just got up a while ago and I don't know if it's mind over matter, but I just got up a while ago and took 2 vitamin C, 1,000 milligrams vitamin C because I don't like what I'm feeling. Like
I look where my answer, man.
And then class done because my eyes are keel over. Did I tell you how? No, I can't tell you because I'm being recorded. I had
the icebreaker, sorry, I can't drop it, man.
I had one of those drinks that that comes in that brown bottle, predominantly brown bottle, you know what I'm talking about. Not the tall one, but the other one, RS, but I had one that was in the tin. And I said, sure, man are grown up now, so man can drink one of them something, you put it for chill, man, and say, yeah. And I started drinking. Blow, whoa, hey. The place started to spin. I start feeling dizzy, I couldn't walk straight. Teacher for the whole I lay down. I get about 12 hours sleep out of it. The following morning I woke up.
So, Mr. Ashan,
Leave me alone, man.
oh, your head will carry kilo, so you can't hold one of them, man. Get light.
Brethren, I got up the following morning and I felt the can. And what would be like about maybe a half tin or maybe a quarter tin or something of the sort. And I went into the kitchen and I poured the rest of it down the sink. I don't want no more. Can't drink it. Can't drink it. And this is what, like maybe is it 5% alcohol in there? I don't even know how much percent. I don't know. Can't drink. Mm-mm. Give me a bottle of Pepsi.
Sir, stick to his soft drink, man.
Yeah, man. Yeah, man. I mean, I have learned my lesson. Stick to the bottle of Pepsi. I should be fine. Can't drink.
Water, man. Water. Not even Pepsi.
Yeah, that is right. Yes. A nice tall glass. Something.
You drink you do it for Uncle Belly, sir.
No, mommy, they don't. When was this? Was this Sunday? No, mommy, they just eat, man. I feel nice and say, you know what? I need something nice to drink. Hey, nice to drink. Nope. And I made a vow that, you know, this is it. Nope.
Already DY the values that you guys got for DYD. Because I'm looking at minus 12x squared plus 2y all over 2x.
It will be best if you substitute the values in there and tell me what you get for the gradient, dy by dx, the gradient. When you substitute it, what you got?
I haven't done it yet. I just wanted to ensure that
Oh, okay. Because I'm seeing two answers here in the chat. And both answers look similar, just that one of them have a negative sign. Yeah, so Alwyn, you want somebody to have the same answer. And then Carno, just double check. I'm not saying that you're wrong, Carno, but just double check something for me, Papa. Just double check and see if you left off something there. But Alwyn, sorry, getting back to this. Where's Rayton? Him drop out of the program? It's long time in the Rayton. Alwyn, you know what is so funny though? You see the flavored ones, I can have it and I'm fine. But why?
Sir, them not have that much you know, in it. Them not have that much.
Okay.
Nothing in the flavored one.
Oh, nothing is in the flavored one. Okay, got you. All right, so I guess I will stick to the flavored one then.
But no, there is a certain level in the flavored ones. So, but I guess it's less than the regular.
You know my conclusion? The whole of them are drunkard. That's my conclusion.
Oh, sir, not like that.
No, Carno, it's when we're talking about
this.
this, Carno, when we're talking about this thing, Carno, you don't get involved, right? Because you know you're rum head.
All right, sir.
Good. You want Alvin. Matter of fact, Kenneth, I don't understand. The cat got Kenneth down because I don't hear Kenneth talk about this. Because Kenneth is a rum.
No, sir, Kenneth is in the office. Kenneth is in the office still. So he's both in class and at work.
Oh, maybe that's why. Okay, so him and not manners. All right. Anybody else finish now? Can I move, please, and thanks?
We can move.
All right.
Yes, sir.
All right. Rajay, I'm not hearing anything from you. All right, so it says find the equation of the tangent to the curve for x cubed minus 2xy plus 5x plus 4. Guys, let me tell you something. You saw me at girls' school? Where was I? I was in high school. And I was doing this in fifth form. This was on the ADMAT syllabus. Let me tell you something. It's when them give me an implicit differentiation. I'll take 1 minute and box this off because it's nice. If it was difficult, I would have told you, guys, it's a difficult topic. It's a nice little something. Watch me. Watch me. I'm finding the differential, so it's going to be 4 times, it's x, so I'm just going to differentiate straight. 4 3 is 12, so this is 12x squared. I'm not going to write dy by dx because it's just x. And then watch teacher now. You have to put this in your parentheses, because it's a negative sign and it's a product rule. It's the first times the differential of the second plus the second times the differential of the first. The first, 2x, times the differential of the second. When I differentiate y, I get 1. What is causes y? Put dy by dx. Plus the second, which is y, times the differential of the first. When I differentiate 2x, I'm going to get 2. Done. When I differentiate 5y, I'm going to get 5. Then dy by dx. And the differential of 4 is going to be 0. Anybody got that?
Yes, sir.
All right, good. Let me just remove the brackets and see if we get the same thing now again. 12x squared, minus, put my parentheses, 2x times 1 is 2x times y is 2x dy by dx plus 2y plus 5 dy by dx is equal to 0. Now removing the parentheses, 2x squared, nope, that's 12x squared, minus 2x dy by dx minus 2y plus 5 dy by dx. All aboard still?
Yes,
Yes,
sir.
sir.
Good job. Love the sound of that.
Right, 2y, that's sorry.
All right, good job. So look at what I'm going to do now. I'm putting all of them together. Now, I don't want to put a negative x in front. So I'm going to carry my 5 dy by dx and put it out front. And then put minus 2x dy by dx. And I'm going to tell you why. I don't want to do it like that because I don't want to make a mistake and leave off my negative sign. All right? So it really doesn't matter if I put the 5 in front or the negative 2x, but I prefer put the negative sign in betwixt. If both of them are negative, that's fine. But once I have one negative, one being positive, best believe I'm going to put the positive one in front. And then now I'm going to write my plus 12x squared minus 2y equals 0. Then I'm going to factorize. So I'm going to have dy by dx into 5 minus 2x plus 12x squared minus 2y equals 0. And then watch me. I'm going to have dy by dx times 5 minus 2x is going to be equal to 2y minus 12x squared. Everybody see what I did right there?
Yes, sir.
Yes, sir.
Divided both sides. Good job. Divided both sides by that.
But even though I never something the sign, sir, the two y's there,
Uh-huh.
with a negative sign there,
Uh-huh.
I still the same thing out.
Good job. Yeah, man, you should get the same thing, I'm just doing the question in a manner that I believe is simplified so that you don't make the mistake when you're doing it. That's what my dy by dx is. That's what I got for dy by dx. No, at the point 0, 1. At the point. Good job.
Question.
Yeah, please.
So need about minus 12x plus 2y minus 2x plus 5 at the same thing. No?
Yeah. You have minus 12x squared plus 2y?
Yes, sir.
Yeah, man, you're good, man. At the same thing, Papa. Same thing. We call it rice and peas. Louisiana call it beans and rice. When you mix it up together, what you get? um, 0,1. 0,1 dy by dx 2 times 1 minus 12 times 0 squared, 5 minus 2 times 0. So therefore, dy by dx is equal to 2/5.
Yeah, that.
All right, now, so
And it's some reach.
so Carno, you were correct. The other two that I saw here, you gave me -2/5. Can you look back for me, please? You know yourselves and confirm if you follow. Before I even move into the third part of the calculation, look back at this one for me, please, and let me know.
Sir, Dede.
I gave you an instruction and say, look at it and tell me what is it, and I'm waiting on you guys. Are we okay with the 2/5?
Yes, sir.
Okay.
All right. So we reach back upstairs late, sir. Somebody that actually started. I see a kickstart part, but another exact thing me have. So what me go wrong? Scroll back up to the top part of the question, sir. I'm really not catch how to start this. So you switch by, you have the first line. Yes, sir. 2x squared minus open bracket
12x. Okay.
12x, yeah. So I have that. I have the dot one
Times 1.
times 1. Yeah, man.
Mm-hmm.
dy over dx. I have times 1 again. I don't know why I have times 1. Exactly. More explain the part there for me. And then I have the times 2. Then I have plus 5y over dy by dx equals 0. But you don't have 5y.
You differentiate in 5y, when you get 5. You follow me?
Yes, sir.
It can't be that. All right, let's just go inside here. I'm differentiating this product 2xy. This negative sign is a negative sign outside here. And then I'm differentiating this 2xy, and then I will I'll use a negative sign hereafter. The first, which is 2x, I write it back, times the differentiation of the second, times the differentiation of the second. And I differentiate the second. When I differentiate y, I'm going to get 1. So times 1. But because it's a y, I'm going to have dy by dx. But it's a y, I'm going to have dy by dx. I'm going to have dy by dx. Plus the second, which is plus y, times the differentiation of the first. When I differentiate 2x, I'm going to get 2. And that ends the differentiation inside here.
So which part will go wrong, sir? Plus the second, actually, because it have 2xy, times the differentiation of the y. Why am I getting times 1? All right. So good explanation. And now you say on my differentiate 5y is 5.
It's 5, yeah.
And because it's a y, I'm going to have dy by dx.
Yeah, very good. All right, good job. All right, Carno, very good, very proud of you, Carno. You got the 2/5. The other ones that I was getting was minus 2/5. Very good. Those of you see the errors, can you pick up where you make the mistake with the minus sign?
Yes, sir. Me kind of so me talk my one from the 2x dy over dx.
Okay. But it's very good though to you got the 2/5. It's just that I know it's from something go, and I don't think you're supposed to have the negative sign there. So yeah, you're not supposed to have the negative sign. I think it's just maybe a typo, not typo, but a miscalculation or something of the sort. But anyhow, so to evaluate the EQUAT equation of the curve, CURVE, I need 2 things. Okay, so why do I feel like this? I need 2 things. 1, a gradient. And 2, I need a point. The gradient M is 2/5. And the point is 0, 1, I think. 0.1. Good. So the equation of the line is going to be y minus y1 over x minus x1 is equal to m, the gradient. So it's going to be y minus y1, which is 1, over x minus x1, which is 0, is equal to 2 over 5. I have two fractions separated by an equal sign. I'm going to cross multiply. 5 times y is 5y. 5 times -1 is -5. Is equal to 2x minus 0. 5y is equals to 2x minus 0 plus 5. 5y is equals to 2x plus 5. Y is equals to 2 over 5. X plus 1. The equation is always given in the form y equals mx plus c, not 5y or 2y or 3y. Y alone. So you have to put it in that form. Y equals. That's the end of that question.
So we get to the last one, y equal to 5x.
Cross multiply. 5 times y plus 1 is equal to 2 times x minus 0.
So we get that.
5 times y is 5y. 5 times -1 is -5. Sorry, you saying?
Yes, sir, but they get up until 5y equal to x plus 5.
Oh, you don't, what you ask me, you don't understand why I get this one?
Yeah.
Hey, Andrew, how are you? All right.
It's all right.
You see now, Andrew?
Sir, we said we just work it out, sir. Just
Mm.
let us drop it, so I just realize that you put it all over 5. And then you cancel out the 5. 5 divided by 5 is 1 and 2 over 5.
Mm. Any other questions? Can anybody find a question? I'm making up these questions out of my head. I need somebody to find a question for the past paper now, so I can work a past paper question so that you don't think that is me just making up random questions. Or, all right, depending on the one that you find, I'll either do it or show you something. Should I? All right, let me show you something first. Let me just show you something first. All right, 10 minutes. But no, not 10 minutes. Sorry, I'm gonna leave it 5 minutes. What I want you to do is to find dy by dx. You're gonna find a gradient for me. You're gonna substitute the value and find a gradient, and don't move from there. Just do the differential, get your dy by dx, make a substitution, and then I'll come back to you. So I'm gonna give you 5 minutes. Those of you who are lagging behind, please start the work. Are you ready?
Almost, sir. Sir, we can still make it, sir.
Go ahead.
Is it negative 2/5?
Again?
That's that.
It might be wrong, but you know.
No, I don't know. It's just that because we got 2/5 earlier, I'm saying, why is it that I'm making up these questions and all of them coming out to be the same thing?
Yes,
Negative
sir.
2/5 is very different from 2/5, and I just wanted to point that out.
And you are correct, too.
So yeah, I got negative 2/5.
Then it's supposed to change this sign at the something else, sir.
Of what, something?
Are the for it? Positive for it. You're not supposed to change when the carry it over. Or is just the first one supposed to change?
Everything's supposed to be positive 6. Yeah, so what I'm going to have is negative 10x, negative 10xy, minus 4x, minus 6.
Right, sir.
So that's correct. It's just that I had a negative 6, so it's supposed to be a positive 6 right here. So yes, you are correct in that when I do all of this, I'm going to end up with a negative 10xy minus a 4x and a minus a 6. But because I have all minus signs, I just factor out. You see it?
Okay, yes, sir.
Mm-hmm. That goes to 0. Negative 4 plus 6 over 5 times 1. What is wrong? Negative 4 plus 6 is going to be positive 2. I get negative 2/5.
Okay, sir. That me get it.
Sorry, same thing you're saying, negative 2.
Good job, Cash. Very nice. Reggie, I'm not hearing you. All right. Now that we're at the point here, anybody recognize a difference with the question, with what was asked in the question? We'll go back to the question. What is different in the question?
Is normal to the curve.
Normal to the curve. Very good. You recognize here that when we're talking about the tangent to the curve, we went to tangent, which is tangent to the curve. We went ahead and used a gradient 2/5 exactly as it is. But when it is normal to the curve now, you have to find a negative reciprocal. Note. Normal to the curve. Please find the NEG, the negative reciprocal of the gradient. So negative reciprocal, so the gradient is negative 2/5. So you're gonna find a negative reciprocal. That means since it's negative, it's gonna become positive. And you're gonna reciprocate it, so it's gonna be 5/2. So the gradient, the normal gradient, M normal is gonna be equal to 5/2. And we're gonna check. The gradient there is negative 2/5 multiplied by 5/2. When you multiply negative 2/5 by 5/2, what do you get?
Yes.
-1.
-1, good. So when you find the gradient of the tangent and the times the gradient of the normal, the product of their gradients equal -1. So what it is that you're doing is finding a negative reciprocal of the gradient. Once it says the question says tangent, you use it as it is. So don't want to man them say normal, you have to find a negative reciprocal, and that is the only difference with this question. If it is tangent, you differentiate it. You plug the values in there. If it's tangent, you're going to use the gradient exactly as it is. Then you find the equation of the line. Y minus y1 over x minus x1 equals the gradient. If it is a normal, you're going to differentiate it. You're going to substitute the value into dy by dx, but we can't use that value because that value that you use is the tangent. You have to find a normal, so you're going to find a negative reciprocal of it, the gradient of the negative reciprocal. Let me explain what this is happening. Everybody knows Ligani, the 4 roads there by Ligani. One road they go take over Barbican, one road all up road, and then the other one they go across Suffering for Barbican, and then one down after 3 come up go for Papine. You know that intersection there?
Yes, sir.
Good. So one way is a tangent and the other way is a normal. So it forms a perpendicular intersection there. Right? So for perpendicular lines, the product of their gradients equal -1. For perpendicular lines, the product of their gradients equal -1. So for perpendicular lines, the product of their gradients equal -1. So any line, any 2 lines that you find, and perpendicular lines are lines looking like this. Sometimes you see them draw it like that. That line is perpendicular. Forms a 90-degree angle. So for perpendicular lines, the product of their gradients equal -1. So if they ask you to find the equation of the normal, you have to find the equation of the gradient of the tangent, and then you can find a negative reciprocal of that and then use it. So the gradient that we're going to use for this question is going to be 5/2. and not -2 physical, we found the negative reciprocal of it. So this is a 1. So this is a tangent, and this is a normal. All right, do me a favor. Finish your question for me, please. 2 minutes. Finish? Anybody got that?
Sir, I have to do it
Yes,
like that,
sir.
5/2x plus 5/2. Could you just
Yes,
leave it
sir. Same thing.
Good
5x
job.
plus 5/2?
Yes, you can't leave it as you can't leave it as 2y. You have to put it in the form y equal.
No, sir. I'm saying I have 5x plus 5 all over 2 instead of you put 2 fraction. That can work.
I would give you the mark here, but yeah, same difference.
Hearing me, sir?
No, sorry, I'm just hearing you now. Go ahead.
Yeah, man, I was just saying, yes, I got that.
Okay, very good, Radley. All right. I am done making up questions. I need for you to go into the past papers. Drop a question or two in the chat, please. We're going to work on work. Come. We need to find a question. Find one, drop in the chat, please. I'll copy it and post it. All right, so again, take them down. Little by little, thanks, Kenneth. Determine the gradient of the curve. Oh, you see? All I want here. Oh, no. Okay. All I want, you see, this is 5 marks. All I want here is to find determine the gradient of the curve. Then we ask you to find the equation of the normal or the tangent. Then just ask you to find the gradient of the curve. So you will end that question right here. So after you do the substitution, because it never asked you to find the equation of the tangent for a normal. So quick and fast. 5 marks, 5 minutes. Start for me, please. And thanks, Sir Kenneth. I really hope that you guys can capture all these questions that Kenneth has placed in the chat, because those that we don't finish up tonight, you notice I'm finishing this topic tonight. You notice purpose driven. So those questions that we're not going to be able to finish tonight will be done at some other time. Quick and fast. Thanks, Kenneth. You deserve a bottle of Pepsi. Not getting a rum. Pepsi. Guys, are you finished? No? Are you finished, guys?
Almost through, sir.
We're taking too long, yeah? All right, hurry up, hurry up.
Anyone else? Anyone else got 7/40?
What was that, 11/40?
No, sir, negative.
Sorry, say it again, Dash?
Negative 27.
Negative 27/40?
Yes, sir.
Oh, anybody got that? Hello, somebody?
I got 27/40.
Oh, you didn't get it, you didn't get the negative.
Oh, sorry.
All right, the pair of you, just do a quick double check and see who put on an extra negative sign. 2 more minutes.
Yes, sir. Negative 27/40.
All right, Taj, that comes to you now, Taj. Double check and see if it's negative or positive.
I double checked it, sir, and yeah, it's definitely negative.
So it is actually negative, 27/40?
Yes, sir.
Well, you owe Alvin a beer, Taj.
But it's the other way around.
Why? No, what you're saying that you work it and you got positive 27/40, that's what you're saying?
No, sir. The other way around. I went said I got the negative 27 over 40.
Oh,
Yes,
so
sir.
Alvin was the one.
I mean the negative sign.
Oh, you eat off the negative sign. Oh, no. You have to go back 2 there. All right, the rest of you guys, please. And you say, oh, Taj, make sure say not spend the money. No, sir. It's the other way around. All right.
I'm gonna do the same thing, so.
Demoy, you have been very silent tonight, Demoy. You've been very silent. I don't appreciate that. Come, the rest of you, quick and fast. 1 more minute.
Yes, sir, finished.
So how would I know that if you don't tell me finish, Papa?
So I tell you about you, I don't never ears about that stuff. You never pay attention to me.
Oh.
So where's the other look at it?
After years, about that.
You go on mute.
All right. I might to understand that the rest of you that are not talking to me, unmuting and talking to me, that you just don't feel like talking, or you're not well like Sir Richards, or is it that you're just not understanding? Which is it?
Well, sir, as much as I'm quiet, sir, I understand, sir. I understand what happens.
Yeah, but talk to me, man. Sure.
Bits and pieces, sir. Bits and pieces.
All right.
So I'm not paying enough attention when I do that on my.
Mm-hmm. Yeah, man, the negative sign supposed to be there for real. You say, sir, you can it? Ah, Jesus, I tell you. And then this is when you be now at the point -3, 4. -3, 4, -3. Two, 3 is 9, 3, 9, -27. 4, 4, 16. 16 times 3 is 48. 48 minus 8 is 40. Guys, it's not you make up the question, you know. I wanna give me in the something. Copy. So I can paste this one here.
Five marks. Very good. Easy and very good.
Blow all this. Let me just tighten this up so I can move it around. Come on, don't be playing with me now. So why would they give you 3 of these? 2 of these rather. I know, say, we're going about and the equation of the normal to the curve at x equals 1. Why would they ask you to find that though? Also, them answer for normal and tangent. Obviously, them not coming in drama, you know. So 6 and 4 and 10 and 8. 18 marks? Low. All right, let's go. We're going to use the quotient rule. Y is equals to x squared plus x plus 2 over 2x minus 1. We're doing the whole question, B and C. Know that we know we can do everything. I've taught you everything on for these 3 questions that we can answer for the 18 marks. So I'm going to ask you to use the quotient rule, the denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squares. You're going to find that. You're going to get that stuff. That's the first differential. You're going to differentiate it one more time. To get your d squared y by dx squared. And then we're going to do something else to do that. So start differential for me, please. Quick and fast. 8 o'clock. Quick and fast. Quick and fast. Quick and fast. How are we so far? Are we okay?
There, but do something else, sir, but to be sure if you're right, you know.
You know that I've always said it's not about being right or being wrong. It's about making that attempt so we can learn from.
All right, sir. So make it negative 9/15.
For which one, Papa?
The C, sir.
Hold on. I was hoping that you would do A first. All right, B. All right, so let me do B1 first. So dy by dx is going to be equal to the denominator times the differentiation of the numerator, which is 1, minus the numerator, plus 2, times the differentiation of the denominator, which is 2, all over the denominator squares, which is 2x minus 1 all squares. dy by dx is equals to 2x minus 1 minus 2 times x is minus 2x, minus 2 times positive 2 is minus 4. That cancels this, and it's all over 2x minus 1 all squares. It means that dy by dx is going to be equal to minus 1 minus 4 is minus 5 over 2x minus 1 all squares. And then it did say find d squared by dx squared when x equals 0. All right. So d squared y by dx squared now, again, it's going to be the denominator, which is 2x minus 1 all squares, times the differentiation of the numerator, and I differentiate a constant, I get 0, minus the numerator, which is a minus 5, times the differentiation of the denominator, which is a power rule. So it's going to be times 2 into 2x minus 1 to the first, times 2, all over the denominator squares, which is 2x minus 1, all squares. We know that all of this goes to 0. D squared y by dx squared is going to be equals to negative 1 times a negative 5 is a positive 5. Positive 5 times 2 is 5 2 is 10. 10 times 2 is 20. So we have 20 times 2x minus 1 all over 2x minus 1 to the 4th power. All of this cancels into that 3 times. So that gives me 20 over 2x minus 1 to the 3rd. And it says to find it when x equals 0. When x is equal to 0, d squared y by dx squared is going to be equals to 20 over 2 times 0 minus 1 cube. What is 20 over negative 1 cube? Therefore, d squared y by dx squared is going to be equal to negative 20. Because when I multiply negative 1 to the 3rd, when I raise negative 1 to the 3rd, I'm going to get a negative 1. 20 divided by negative 1 is negative 20. Look at the question. Look how easy it is. And that was 4 marks. They asked you to find d squared y by dx squared. You're going to first find dy by dx, and then you're going to differentiate dy by dx one more time to get d squared y by dx squared.
Sir,
Questions? No.
yeah. Is there a next way you could have worked out? So the line that we have.
Which one?
dy by dx equal 2x minus 1 minus 2x minus 4.
Yeah, all I did was just to distribute. All I did was to distribute.
No,
Two
not a
x
line
squared.
there, sir. No, but
This.
yeah,
Yeah, that's what I'm saying. So I'm showing from here. So 2x minus 1 times minus 1. Minus 1 times 2 is a minus 2. So minus 2 times x is a minus 2x. And minus 2 times a positive 2 is a minus 4.
get that to the sir.
What are you asking me then? I don't know if I follow you.
I do something stupid. It's like I think I catch it, but I not catch it. Instead of 2x minus 1 there for the first part, I kind of divide it into the 2x minus 1 r squared for the denominator.
You can't divide through beside a negative sign or a positive sign. You have to first bring it to a complete fraction. Let's combine the fraction first. You can't cancel out this with one of the denominator factors. That's illegal. So you have to first combine the numerator before you can do any cancellation. I know exactly what you're talking about. That step is illegal. So what I'm doing right there is just distributing the 2x minus 1 by 1, and then the minus 2 times x is minus 2x and minus 2 times positive 2 to negative 4.
Yep, I have that.
Yeah, but no, you can't. You can only divide or cancel by beside a negative a multiplication sign. No other sign.
Noted.
All right. Do you recognize that part 2 is connected to part 1? Or you didn't recognize? What am I talking to? Self?
Did you recognize, sir?
You recognize it, Alwyn?
No, sir.
Yeah, man. Part two, they're related. It says find the equation of the normal to the curve at the point x equal 1. What is the function that you using? Which function we're using to find the equation of the normal at the point where x equal 1? Now, the one up top, y equal all of that. So those are related. It says to find the equation of the normal to the curve. Normal to the curve at x equals 1. Negative 5 over 2x minus 1 all squared. Negative 5 over 2x minus 1 all squared. Negative 5 negative 5 over 2x minus 1 all squared. You need to find the gradient at x equal 1. That's what the question said. Gradient is not d squared y by dx squared. Gradient is dy by dx. So to find the equation of the normal to the curve at the point x equal 1, dy by dx is going to be equal to negative 5 over 2 times 1 minus 1 all squared. Negative 5 over 2 times 1 is 2. 2 minus 1 is 1. 1 squared, which is equal to negative 5. But the question says, find the equation of the normal. Negative REC.
Yeah, I'll find negative reciprocal.
Right, reciprocal. Very good. Reciprocal. So reciprocal. 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 Reciprocal means reciprocal.
Invert.
Right, we can flip, yeah.
Sir, yeah, but Mr. Minor, sir, so you call tonight.
Not that thing, not stomach with you. You force me to hear that. So you're talking, you never stomach.
And this is reciprocal.
Reciprocal.
See?
Pro?
Reciprocal.
Right. Reciprocal, right. Right. So so what is going to happen now is so dy by dx is a gradient of the normal now is going to be equals to 1/5. Because when I multiply 1/5 by 5, I'm going to get negative 1. And remember, this 5 is 5. This 5 is the same thing as that negative 5 is the same thing as negative 5 over 1. So when I flip it now, I'm going to have 1 in the numerator and 5 in the denominator. See here? Boom. 1 in the numerator and 5 in the denominator. But because this is already negative, I'm going to flip the sign. So this has to be positive. So this is going to be the gradient of that. Now, I'm going to show you something else. I'm trying to trick you, but we're going to decode it. X equal 1. They never get a y value. It says find the equation. To find the equation of a line, I need 2 things. I need a point and a gradient. Talk truth.
Yes, sir.
Good. So I need to know the y value now. But them say that the point x equal 1. X plus 2, 2x minus 1. X plus 2, 2x minus 1. So y is going to be equal to 1 plus 2 over 2 times 1 minus 1. 1 plus 2 is 3 over 2 1's 2. 2 minus 1 is 1. So it's going to be equal to 3. So therefore, my coordinate is going to be, my point is going to be 1, 3. Very good. And my gradient, the normal gradient, is going to be equal to 1/5. So to find the equation of a line of that is going to be y minus y1 over x minus x1, which is equal to the gradient. So y minus 3 over x minus 1 is equal to 1/5. 2 fractions separated by an equal sign. I cross multiply. So this is 5 times y minus 3 is equal to 1 times x minus 1. 5 times y is 5y. 5 times 3 is 15. Is equals to 1 times x is x. And 1 times negative 1 is negative 1. 5y is equals to x minus 1 plus 15. 5y is equals to x plus 14. Divide both sides by 5. I'm going to have y is equals to 1/5 x plus 14 over 5. And that's your answer. You have to use the man them trying to trick you. The man them trying to trick you. Don't be tricked. The man them give you x equals 1. They never give no y value. But do you have an equation in terms of y? Yes. See to yourself. Substitute this value into this to get the y value. And you already calculate the normal gradient, you're good to go. All right. When you get the document, just look over it and see if you can follow what is happening. All of that is 10 marks, 10 full marks. All right. Somebody help me with this, please. X cube. Anybody? I need help with this one. X cube minus 3xy squared. 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 What again? Oh, Jesus.
Y cube, sir.
Y cube equal 1. Thank you, Papi. Y cube equals 1. So my bonus not sleeping, you know. But let's go. What the question asked me to do? The question asks me to find the equation of the tangent. I want the tangent, so I don't need to find the negative reciprocal. And at the point 2, -1. Let me just write that here from now. 2, -1. At the point 2, -1. All right. 3x squared minus the first times the derivative of the second, 2y dy by dx, plus the second, y squared, times the derivative of the first, times 3 plus 3y squared dy by dx equals 0. And differentiation ends right there. I'm going to have 3x squared here, minus, fix up inside here, 2 times 3 is 6, 6xy dy by dx, plus 3y squared, plus 3y squared dy by dx equals 0. So this is going to be 3x squared minus 6xy dy by dx minus 3y squared plus 3y squared dy by dx equals 0. I'm putting all the dy by dx's together as you would have seen me do, but I don't want a -1 in front, so I'm going to put the 3y squared minus 6xy dy by dx plus 3x squared minus 3y squared equals 0. Are you with me so far?
Sir, but they put the 3y squared first, sir.
That's fine. That's fine. Should get the same answer now. So therefore, I'm going to have 3y squared minus 6xy dy by dx is equals to 3y squared minus 3x squared. And then I'm dividing both sides by, interesting, 3y squared minus 6xy, 3y squared minus 6xy, all of that cancels all of that. So dy by dx is equals to 3y squared minus 3x squared all over 3y squared minus 6xy. I'm not interested in factoring in reducing my fraction. Why? Because I'm asking to find the equation of the tangent. And this is when it occurs at the point 2, negative 1. 2, negative 1.
Sir, why we
Dy by-
could cancel 3y squared?
No, can't. You can't cancel beside a positive sign or a negative sign. That cancellation is illegal. I think that's what one of the things something was asking earlier. Can't cancel those things because that 3y squared is not 3y squared by itself. It is 3y squared minus 3x squared. So that 3y squared is married to somebody else. That 3y squared has something depending on it. Similarly, the 3y squared in the denominator is also married to the 6x, no, the negative 6xy. So I can't just go and break it off like that. All right. Which is equals to 3 times negative 1 squared minus 3 times 2 squared all over 3 times negative 1 squared minus 6 times 2 times negative 1. That's 1 negative 1 squared is going to be positive 1. Positive 1 times 3 is 3. 2 is 4. 4 times 3 is 12 minus 12. Negative 1 squared is 1. 1 times 3 is 3. Negative 1 times 2 is negative 2. Negative 2 times negative 6 is positive 12. And look at this now, Ashanti. Somebody may say, then, sir, you couldn't just cancel the 2, 3 them here, and then the 2, 12 them and leave with negative 1. No, that's illegal. It's illegal. Not going to get the same answer. So 3 minus. Yo.
That's what I got.
What you got? 9 over 15?
Negative 9 over 15. Yes, sir.
So may I ask a question? Anything said that done?
No, sir. Can go down.
Okay, thank you, please, sir. So dy by dx is going to be equal to negative 3/5. Oh, but the question I done it, you know, because the question says we're supposed to find the equation of something down. The way it say the equation is the tangent of the curve, don't?
Yes, sir.
All right. So if the tangent of the curve, then I'm going to say the equation equation y minus y1 over x minus x1 is equals to m. Y minus y1 is, what that 2, 2, is it 2, 1? What was it? 2, negative 1. Y minus and negative 1 over x minus 2 is equal to negative 3/5. I have 2 fractions separated by an equal sign. I cross multiply. So this is 5 times. That works out to be y plus 1 is equal to negative 3 times x minus 2. 5y plus 5 is equal to negative 326x. 326 plus 6. Rubbishness. 3 times x and 3x. Three times x is 3x. Same way, so. Same way, so. One eye shut and one eye open. All right, and then we can have 5y is equal to negative 3x. I would have picked it up when I reach this line. I'm going to show you how. 5y is equal to negative 3x plus 1. Y is equal to negative 3 over 5x plus 1 over 5. And this is going to be the equation. I will tell you how I would have picked it up, Alwyn. Whenever I write my equation in the form y equals mx plus c, I would have recognized that the gradient would not have given me 3/5, which is what I'd gotten up here. So I recognize that this is my gradient. Dy by dx is the same thing as m, the gradient. So if you go into the exam and them ask you, give you another name for dy by dx. It's really the slope. Give you another name for slope. Gradient. Give you a symbol for gradient, m. So all of those things mean the same thing. So when I reach right there, so I recognize it, but hold on there. When I get 6 something, that don't make no sense because the gradient was -3/5. So when I get my equation in the form y equals mx plus c, I can immediately read off my gradient.
So that's a way we can determine if our equation is wrong.
Yes, I.
Gradient is not in the equation.
Right. So that's why we want to write it in the form y equals mx plus c, not 2y or 3y. So dege y. We want y equals whatever it is. And when you look at that, the value of the mx, the value of the m is the gradient. And if that don't resemble the gradient that you calculated before, something wrong.
Yes, sir. I see science behind it now.
Nice. So you see the mere fact that it's just a few of you talking to me, I recognize that you guys are tired. But I just want to do one more question. And you notice what it is that I did? I did to stop and say you're understanding because I know when you're going to tell me or when you're not going to answer because I know I'm tired. I'm tired too. But I thank Kenneth for the questions and I'm going to work one more question and then let me see how this one looks. And then we'll call it an evening or Rockstone. You know what happened? I created 11 pages. I'm done the 11 pages. Never have problems of generate on next something. Let me see if I can get another insert. Undo. Never realized I was at the end of the page, you know.
Sir, probably the problem why so much persons are quiet is because we have a deadline to meet tonight with a project. So probably that's why.
Oh no, when you say something there, no? All right. True, me can't get no more page band or something, yeah? It's kind of sealed, you know. No, man. Listen to me now, students.
I'm telling you, there's no problem. That is exactly what it is. There's no problem.
What is the problem? There's no problem for what?
There's no box that said probably. So I'm saying it's not a probability at this point. It's certain. It's certain that that's the reason why, people are in
Yeah,
bed.
but
That
see, what I'm saying to you, say something to me because me we go along and teach, you know, and they may go come back to class and go here, sir, I didn't understand this. Well, only that I do some other homework. Say to me, sir, you did promise that we're going to go up until 9:30 tonight, but can we do something else? Hey, me understand things, you know. This is something to me, man. Let me go along Sunday and after that now. That's something I get the participation from. Oh no. All right. What I'm going to do, I'm going to stop here. I'm going to stop here because.
Sir,
No.
as it relates to, say I use some equation like you have the y equal mx plus c. You did send notes on that, sir?
No, sir.
Okay. Okay.
Because it is
I
expected.
remember to send all that you did tonight, sir.
It is expected that you would know what is going to be required of you. It's a prerequisite. So it's when when I come to class and I say you have to have the prerequisite to come to the something, this is what I'm talking about. If you don't have the prerequisite knowledge, you're going to be having problems. If you don't have the prerequisite knowledge, you're going to be having problems, and this is not going to work out. If you don't have the prerequisite knowledge, it's not going to work out, and that. But anyhow, your notes is shared, and make up on yourself. Have a good night. We will talk on. Oh, Rockstone. Hold on. Hold on. When does exam begin?
Exam begins on the 10th of December.
On the 10th of December.
Yeah,
Or
but
the
it
9th.
starts with
I think
calculus.
your exam is the first one you have to.
Yeah, it starts with calculus.
Are you serious?
Yes, sir.
Yes, sir.
Exam starts on the 9th, you know. So is it that you have calculus on the 9th or calculus is on
No,
the
the
10th?
10th.
The 10th,
Calculus is
sir.
on the 10th, sir.
All
I
right.
think
So
it's
let
a
me just,
morning exam too.
okay, great. Let me just tell you something now. So the college has, and I know that I'm being recorded and I can back it up. The college says that so next week technical should be my final teaching week. I know some of your other lecturers may have completed the stuff. Those easier courses may have already been completed. You know, your administrative com and your HRM and then something there. Yeah. But this one no. You see the week when them say it's gonna be a study week, best believe I'm gonna meet with them 2 days earlier because I need to finish off the stuff. Having completed implicit differentiation, I must start integration. I have not done any integration with you. And you can get integration with itself. So I don't have much more to go. I may have about 2 areas from memory. I need to look upon it, but it can be done. So we have next week, and that other week I want to meet with you, right? And then towards the end of that week, what I normally do with students is to guesstimate what I believe the exam is going to look like. And then I say to you that, I'm expecting a piecewise, I'm expecting limits and continuity. Limits as x tends to something, tend to infinity, tends to negative infinity. I'm expecting the stationary point question. I'm also expecting the implicit differentiation. I'm expecting differentiation. I'm expecting integration. And then we can just play around with it and then leave, stationary point students must come. And you know what is what
Sir.
Go ahead, Papa.
If you say if this come on stationary point, the stationary point need a little work, but this will do so far a catch up.
Very nice. What I feel may come, well, what I know will come for a fact is your stationary points. What I feel is coming to stationary point is a question for 30 marks. If it doesn't come for 30 marks, it cannot come for less than 20 marks. And if it comes to 20 marks, I'm expecting one of them piecewise question function here with the unknown A and B. I'm supposed to find A and B that is continuous over the whole range. And there goes your 30 marker. Or it is the stationary point for 20 marks, and then you may have an implicit differentiation for another 10 marks. What could also come is if stationary point comes for the full 30 marks. What could come is the stationary points for full 30 marks, and then you have say the piecewise function. Then you may have the implicit differentiation, and then you may have another something. So right about there, so you have about 20 marks, right? What's the point I'm making? The point I'm making is I'm expecting the paper to come in a manner where you guys can truly manage it. I don't foresee I don't foresee any great grandiose difficulty with what it is that we're doing. I don't foresee that. I need to finish off the syllabus first before I can, go through the things that we're doing. I'm aiming to finish off the syllabus next week, and then that week within your study break, I want to use that along with you to study. So I won't be it is my hope, my expectant hope, that I won't be introducing anything new within that study break week, but I can only be able to reinforce what it is that we've done over the semester. Yo, don't play with me. So I'm going to work for do. Want to do it. All right? Big up on yourself later.
All right, much respect.
Come on, easy.
All right, sir. Bless up.
Come on, cool.
Remember, don't drink and
Appreciate it,
drive, you know.
Yeah,
Try
man,
not to.
take care of the room, sir.
All right, easy, Papa. Easy, easy.